To perform pick-off cutoff operations, often referred to as POCO, there are a few requirements of the machine in Mastercam. First, the machine must be defined as having a subspindle. The subspindle is referred to as a right spindle for this Mazak QTN machine. The subspindle must also have a Z-axis associated with it so the spindle can move to the fixed main chuck and grab onto the material. Lastly, your post-processor must support the use of these POCO routines. With these in place, you are ready to start a POCO operation. On this sample part, the machining of the first side is done, and now we would like to transfer the part to the subspindle. Under Part Handling, I will select Pickoff, Pull, Cutoff. You will then have to tell Mastercam what spindle is currently holding the part you wish to pick up. For this example, the part is in the main or left spindle. Once selected, the main dialog menu for POCO will appear. The menu consists of two tabs: the Setup tab, where you will enter in values for the process, and an Operations tab, which will show you the operations used depending on the process selected. With no operations selected, the Operations tab is blank. If the process of pickup, bar pull, cutoff is selected, which is the process I will use for this example, the Operations tab will show all of the operations needed to complete the process. First, start on the Setup page. Since I have done this previously, some of my fields have been populated already. I will zero these out so we are starting fresh. Select the geometry for the operation. If desired, the Translate Geometry button can be enabled so that the new geometry is created in the opposite spindle. Set the desired option for the level of this new geometry. If you are wanting to perform additional operations on the part once it is in the subspindle, it may be necessary to create a new plane. This can be done by enabling the Create Named View button and then selecting the appropriate face for origin. You can also have stock automatically generated for the subspindle by enabling the Generate Pickoff Spindle Stock. The values for the process must now be populated. Starting at the top, it is the length of the part. If your selected geometry is the actual length of the part, clicking the From Geo button will grab this length automatically. If not, key in the correct length. If you know the Z coordinate of where you would like to grab the part, it can be entered, or use the selection icon to snap to a location and return its Z location. The cutoff width represents how wide the cut of the part off tool is. If you know the value, key it in, or use the tool selection button to get this value from a tool in your library. Next is the setting for the diameter which the part off starts from. For this example, from stock is adequate. Last, set the amount of stock, if any, you want to leave on the front and back faces of the part. Before proceeding, let's review the process on the Operations tab and set the custom parameters needed to result in the desired pickup motions. The first op is the pre-positioning of the cutoff tool. The X and Z location can be altered if needed. Op 2, as the comment suggests, is an unclamping of the subspindle and part eject. Exactly how this operation behaves for the eject will be dictated by your post-processor. There are, however, some options we can control using custom parameters. These custom parameters are available for all chuck operations in this process. You can have control over the amount of dwell time, if any, during a clamping operation. You can dictate the movement type, rapid or feed, during a chuck movement operation, and if a feed movement is used, the feed rate can be set. There are recommended motion types to use based on the operations being done. Please follow these recommendations, which we will go through now. This unclamp eject operation has no movement, so parameters for motion type and feed rate are not valid, but you could specify a dwell time if needed. Op 3 is for the subspindle to move to the clearance position for pickup. This is typically done in a rapid motion, so in the custom parameters, ensure the reposition mode is set to 0. You can also set an appropriate approach distance. Next is the move to the grip position. This is typically done in a feeding motion. Set the reposition mode to 1 and set the feed rate amount to use. Next is the clamping of the subspindle onto the part. There is no Z movement, but you may want to add a dwell amount to this to ensure the chuck has time to complete the clamping process. This can be repeated for the next op as well, which is the unclamping of the main spindle. The next operation is the pulling of the stock using the subspindle. Typically, you will want to use a feed motion for this operation. Set the mode to 1 and apply a feed rate to use. Next, the main spindle will reclamp. Again, no motion for this op, but a dwell may be desired. The next operation is the actual cutoff toolpath. A different operation can be selected as well as a new tool defined for the operation. Keep in mind this can also be edited after the process has been made. The last op is the subspindle retract. This is typically done with a rapid motion. With all these settings made, click OK and Mastercam will create all of these operations. It is necessary to be sure the motion type is set correctly for the ops in which motion is occurring. Op 6 should be a rapid motion. Double checking the custom parameters shows 0 for the motion type, which is correct. Op 7, the movement to the grip position should be a feed motion, which is correct. Op 10 is the bar pull, and it too should be a feed motion. Last is Op 13, which is the subspindle retract, and that should be a rapid move. More checking can be done in backplot or by moving the operation arrow. A review of the posted G-code is made simple by the additions of the operations comments. Since this post is not set to perform any specific functions for a part eject, only the comment is shown in the line of code where this would take place. If your machine is capable of an eject, you would see the appropriate M code here. You can also see the clamping and unclamping of the chucks with M307 and M206, as well as the G04 dwell to allow these motions time to complete. Your post will output the G and M codes that your machine requires to perform these commands. It may be different than what is shown. Your machine may also have additional options in the custom parameters. For example, if I switch to a different machine, I have custom parameters to define torque limit and skip values. The options available to you in the custom parameters will vary depending on your machine.